In this lab, we are going to be taking a bit more of an in-depth look at recursion. When we talk about a recursive function or recursion in general, we're talking about functions that call themselves. And these functions have two parts to them. They have a general or recursive case, which is when the function will call itself providing in the input a smaller version of the number or result that it had taken in. And it will keep doing that and keep calling itself getting the answer smaller and smaller until eventually it reaches a base case in which there is an end solution. You can't go any smaller. And it will start from there and start evaluating all the way back up the chain of recursion until you get the answer that you wanted. And a very popular example for this is a factorial. So when you have a factorial, you're timesing the number you started with by every number all the way down to 1. So for example, if you had 4 factorial, you would have 4 by 3 factorial. This would be a recursive step. 4 by 3 by 2 factorial. 4 by 3 by 2 by 1 factorial. And as factorials can't be negative, once it sees 0, that would be your base case, and it would start evaluating back up the chain. So 4 by 3 by 2 by 1. This is where you'd start getting your answers from. We have a sample implementation of how that might look as a function here. So this is our function call. It takes an integer n. It has a result here. If n is 0, that will be our base case. It will just return 1 as the result. If n is not 0, it will call itself here with n minus 1. So if you were starting at 4, factorial of 4 will call a factorial function of factorial 3, which would call the factorial function for 2, calls for 1, and then eventually it reaches its base case of 0, which just returns the result of 1. And then once all these calls are made, it will evaluate them bubbling up in reverse order. So it starts from a result of 1, 1 times 2, well actually 1 times 1, 1 times 2 for 2, 2 times 3 will give you 6, and 3 times 4 will end up with the result of 4 factorial, which is 24. So we have some examples of how recursion can be used for various things that you might be interested in looking at, but what we're going to be most interested in this lab is how recursion works in linked lists. So one of the most common things you'll use recursion for throughout any of your CS studies will be traveling through data structures, very commonly linked lists. And we have a couple of function examples here. We have a write function, and the way this one is implemented is instead of just having the write function call itself, the write function is actually going to call a subroutine that does the recursion for it. So essentially all this write function is doing is it's putting the pointer to the head of the linked list and calling the write subroutine, and a bit more console output management around that. And then the actual recursive function here will be write subroutine, or write sub. What this will do is as long as the pointer is not null, it will print out the data item and then call the subroutine for the next node in the list. And that will just keep going on until it reaches the end. And then since it's not going to print out a result, it'll basically just start returning void since there's not a return type. And it'll just return void all the way up the list until that whole process is done and it moves on to the next steps with different functions or commands. So it starts from the head. If the first node was an A, it would output A, go to the next node, output B, go to the next node, output C. It would try to go to the next node. There is no next node, which means that P equals 0. So it starts returning void and ends the recursive function. Another example would be if we wanted to insert a node to the end of a linked list, and the following functions here and here can do that. We have, again, our main insert end function, which will take the data item we want to add to our list, But all this one is going to do is call the insert end subroutine by providing the head pointer again and the item that it wants inserted. This is going to be, again, our actual recursive function. Here, this is our recursive part. If it's not at the end of the list, so the pointer's not at a null, then it will call itself again to go to the next pointer, and it will keep passing the data item that it wants to add to the list. Eventually, it'll reach the end of the list, so p will equal 0 or null, in which case that is our base case, and it adds the list here. So the pointer becomes a new list node with that data item, and with its next pointer being null or 0, and the cursor set to that pointer. And then it would just sort of void up the rest of the list as before, and the recursive function would end. So the head goes down, base case. If you were inserting an exclamation mark, it's passed all the way along. You have to do it that way, or else you'd have to use a global variable, which is not what you'd want it to do. And it creates a node here. Which would look something like this.